Good morning, ladies and gentlemen. We are Team ICT, short for NCAR Tech. And as shown on the screen, we are a heavily weighted on big data and AI technology. And today we'll be conducting a presentation for our project, which is on car component status predictor. Now, before we get into the details, these are our team members, Hejun, Philip, Yunzo, and myself. And moving on to the table of contents, first we'll be introducing about the background as to why we chose this topic, and move on to talking about the concepts and detailed ideas, and then to our technical approach, and finally give you a brief summary of our user research, and in conclusion tell you about our future plans and direction. So to start off, according to statistics, countless accidents occur today due to the lack of periodical vehicle inspection, which is why we thought it was crucial for some kind of interaction to happen between the driver and the vehicle. And so we came up with our idea of an interactive smartphone application in order to prevent potential accidents. So this, as you can see on the screen, is our basic prototype on paper, and Yunzo will explain it further for you.
I'm going to talk about the concepts and details ideas of in-car system. A model to predict to the entire inside of the car will take a huge amount of time. Our prototype will more focus on the car lamps, since the coordinations and the functions of them are organized in a manner that makes initial modeling less difficult than other parts. According to the sketch prototype illustration, we can know more detailed ideas of in-car system. To begin with, in order to predict and inform the internal temperature of the car, it should gather internal temperature data from clients. Moreover, the given data set should pre-process and analyze its data. And then it will begin modeling to predict component temperature through using linear regression, and its evaluation index will be RMSE and R-squared. Finally, there will be interactions between human and computer in this system. Computer to human interaction will be the car system analyzing the driving course and informing the drivers about the predicted temperature by displaying on the mobile application's screen. In addition, human to computer interaction will be the user asking the car system about the predicted temperature of the car, and the car system will be answering about the question back.
To continue on into our technological prototype, as Jensa has said, we want to make a realistic, implementable prototype. And to do that, we shorten the range of a prototype, lamp for the component, temperature for status. We will run linear regression using our language, and our data set is shown in the presentation. And to give you a short explanation about the data, we have 9 variables, including XYZ coordinates, the bulb type, and then we created 2 variables, distance and volume, using the 9 variables given. Also, we have about 500 cases, and we are planning to receive more. Lastly, our dependent variable, which is a variable that we are trying to predict, is temperature. In the dataset, it is a variable named temp_C. We use the equation as shown here, and we tried multiple regression. Our results showed that all of our coefficients were statistically significant. We did the regression by dividing our data set into train and test sets randomly. Our test evaluation was RMSE 29.59 and R-squared 0.92. And that is room for improvement. We did residue analysis of our model. Although variance was passed to be satisfied, the normality test failed. And that means we need to improve our model. We will improve our model first by attempting regression on average temperature of identical situations. Next, if that doesn't work, we are also planning to try nonlinear regression.
To receive a variety of feedback on our system, we conducted user surveys. The sequence of user surveys was as follows. First, we proceeded in the order of development: background, sketch, prototype, paper prototype, survey, and finally we received feedback. What you see on the right side is the questionnaire form we used and consists of 6 questions. Next, the photos you see are taken to record how we actually went to about doing user research. User surveys were conducted offline, online, and via call. The following are the user survey results and implications. Through this investigation, we find that users want to deal with various situations through interaction with the car. And we also find that users want to interact with the car in a more convenient and simple way. Finally, I want to share our future plan and direction. The user survey conducted this time had a small sample, so next time we plan to conduct larger user research to obtain more accurate results. Also, deeper research on car component status will be conducted, and we will continue to narrow our ideas further to create a clearer concept. And above all, we will develop a more robust system by considering how users can cope with various situations through effective interaction with the car. That's it for this presentation. Thank you for your attention.